How can we determine whether a linear transformation is a one-to-one function? In review, a function f with domain x and codomain y is one-to-one if for every element in the codomain, there exists at most one element in the domain that maps to it. If there are any elements in the range that are mapped to by multiple elements of the domain, then the function is not one-to-one. So for any element b of the codomain, we want to be able to show that there's only one element x of the domain that maps to it. Consider some particular vector xp that maps to b, and xn, a vector in the null space of A, which tells us that it maps to the zero vector in the codomain. Now consider the transformation of the sum of those two vectors. Since linear transformations are distributive over vector addition, we can rewrite the sum like this. But we know that our vector in the null space maps to the zero vector, so it cancels out, leaving us with the transformation of just our particular vector that we already know maps to B. What this tells us is that if we have a particular vector that maps to B, we can add to it any vector in the null space, and that will give us another vector that maps to B. So if the null space contains more than a single vector, then for any vector B in the image, there will be multiple vectors in the domain that map to it, and so the transformation isn't one-to-one. Our conclusion is that a linear transformation is one-to-one if and only if its null space contains only the zero vector. And that's the case if and only if the column vectors are linearly independent. And that's the case if and only if the rank of the matrix is n, where n is both the number of matrix columns and the dimension of the domain.